Everyone, and welcome back to another video. In this one we are going to discuss about one of the most important topics, which is the easiest. You just have to remember the formulas clearly and you'll be through. So it's a very easy, very scoring topic. Let's get right into it. So index numbers. So index numbers are something which quantify the changes that take place over the time, right? In certain fields or certain group of fields. So let's say you want to compare the price of the goods from one period of time to some past period of time, right? So you cannot directly compare it. You cannot just say that okay, this cost was this much earlier and now it is this. You have to standardize that entire process. So this is where we are going to discuss about index numbers. So let us first start with price index numbers. In this we will only focus on the change in the prices. Okay, so there are different types of index numbers. The one of the most basic one is known as simple average. So what you do is you sum up the prices of goods from one period divided by sum of the prices from the previous period, or base period we call it. So the period from which you are comparing it with is known as the base period, and it always goes into the denominator. So you sum up the prices into 100, it will give you a index numbers which is based on simple average, right? Now this becomes very basic and we kind of ignore some factors here, so hence we come up with a new idea which is weighted average, which is better than simple average. So in this you can have weights, and that weight could be anything, right? So if we take example of Laspier's index, in this what happens is your weight, this weight is nothing but the quantity of the base period. Okay, so what we are doing is we are summing the prices into multiplied by the quantities of the base period divided by sum of the prices of base period into quantities of base period into 100. So this is your Laspier's index, Laspier's price index. This is also known as consumer price index. Very, very important thing to note. This is your consumer price index, or also known as cost of living index, right? Now what happens is, in this case we are actually overestimating. Okay, we are overestimating the value because, as you must know, that over the time we cannot say that the quantity which was consumed in the base period is same as the quantity which is being consumed today, right? There is always some decrease in the consumption because of the increase in the prices. So this is something which is not accounted here, and hence we end up overestimating the value. Okay, so this is also a very important point. Next one is Paget's index. So in this one, the weight, as we talked about, in Laspier's the weight is the quantity of the base period. However, in Paget's, the quantity is of the current period, and hence what happens is that we underestimate the value, because again the quantity consumed in the base period is more, so we end up underestimating the value. We will quickly see an example to understand this concept better. So as we discussed in the formula, Laspier's index is summation of Pij into Qoj. So Qoj is the quantity of the base period. So here your base period is 2018 and this is your Qoj, right? And this is your current price, this is your Pij, and this is your Poj, price of the base period. So what we do is we multiply Poj and Qoj to find out the denominator. So which will be 1 into 4, 4 plus 6, which is 3 into 2, right? And Pij into Qoj. So we do multiply this and this. So we multiply 4 into 2 and 2 into 4, we get 8 plus 8. And hence our Laspers index is 160. On the similar lines, you can calculate your Paget's index. So I want you to do this exercise yourself and check your answer. You should get 150. Okay. Now I will move forward. Just for your hint, this is your Qij. So you can quickly solve this question and check for yourself. Next is your Darvish-Bawley index. So Darvish-Bawley index is nothing but the average, or you can say the arithmetic mean of Laspers and Paget's index. Next up we have Marshall-Edgeworth. So in Marshall-Edgeworth we are doing the right thing. That is, we are adding the quantities of both base period quantities and the current period quantities. And this is how you calculate the Marshall-Edgeworth index numbers. Now comes the ideal index numbers. The ideal index number, which is your Fisher's index number. So Fisher's index number is known as the ideal index number. It is the geometric mean of Laspers and Paget's index. So you multiply both the values and take the, that is basically you take the geometric mean of Laspers and Paget's index to find out Fisher's ideal index number. This is a very important one, and we will know in a moment that why it is known as the ideal index number. So there are certain criteria which tells us that this is a good index number. So there are a couple of tests. If your index numbers passes those tests, you say that the index number is a good index number. So first one is the unit test. So unit test is basically that your index number should be independent of any unit. It should not be that this much rupees, this much kgs. It should not be that way. It should be independent of any unit. So all our index numbers are independent of any of the unit because the units get cancelled out, right? Time reversal test. So time reversal test basically is that if you interchange the period, right, and you multiply them, it should be equal to 1. So we say that Fisher's index follows time reversal test. That is, if you try to compute this value, that is you multiply POI into PIO, these are the index numbers, you will get it equal to 1. So I have taken a quick example here. So PIO of Fisher's will be something like this because we are taking the geometric mean of Laspers and Paget's. So this is your Laspers, this is your Paget's, and this is where you are taking the geometric mean. Similarly, it's POI, okay? POI is something that we are defining. So it will look like something, and it will look something like this. And now it is very much evident that if you are going to multiply this, everything is going to cancel off, right? So this gets cancelled off with this gets cancelled off with this one with this, and this with this, right? And hence you will get it equal to 1. Next up is the factor reversal test. So we talked about price index. So as we have price index, we also have quantity index. So if I have to define QOI, which is our quantity index, it will be defined as, let's say we define it for Laspers, right? So in Laspers, what do we usually have? Your Laspers looks something like this, right? This is what it is. So you replace the price with the quantity. So Qij into Poj divided by summation of Qoj into Poj. So this is your quantity index number. That's it. You replace, that is, you interchange the price in the quantity. So for factor reversal test, if you take an example of Fisher's only, because Fisher's is the only one which satisfies the factor reversal test as well. You can solve it for yourself, right? So you take Fisher's POI and QOI, right? And if you multiply it, you will get this value. And this validates that it follows factor reversal test. Next up is the circular test, which is nothing but an extension to the time reversal test, and it is defined something like this. So even Fisher's does not satisfy circular test, right? So this is it for this video. If you have any questions, please feel free to add them in the comment section, and we will. Thank you for watching.